morning class. I am Miss Jessie Baring, your instructor in Physics 103.1. Before we proceed our laboratory, I will check your attendance first. So everyone are present. Okay, very good. So please listen class because this activity is very important. Okay, so our laboratory for today is all about characteristics of a wave. First is your objective. Your objective is to investigate the characteristics of a wave using a toy slinky. Second is materials. First is a long coil spring, slinky or a rope. Second is stopwatch. You can use your cell phone for the stopwatch. Third is the meter stick. Drawing. Then you can. Third is the drawing. You can also refer to this link. Next is fourth procedure. First procedure. Go to a place where there is a clear path of about 6 meters. Second, stretch the slinky slowly to the length 5 meters. Third is be sure to firmly grip the slinky with one hand. It is better to see the motion of the slinky if you are near one end. Don't watch from the side. Fourth, you will feel the pulses of the slinky until they die out. If produce a transverse pulse in the slinky by making a quick sideways snap with your wrist. 6. Observe the number of times the pulse will move back and forth in the slinky. 7. Design and conduct an experiment to answer the questions in the observations and data portion. 5th, data and observations. Your data and observation are: first is what happens to the amplitude of a wave as it moves. Second, what happens to the speed of a wave as it travels. Third, is the speed dependent on the amplitude. Fourth, try making two quick pulses into the slinky. The distance between these two pulses is called wavelength. Thus, wavelength change as the pulses move. Fifth, is there a way to decrease the value of the wavelength? Next is, fifth is your analysis of results. Do the pulses bounce off each other or pass through? Second is, you probably use transverse wave for this experiment. Will you answer be accurate for longitudinal waves? Then explain. 7 is your generalization and conclusion. Write your conclusion to your class. So this laboratory is very important. So I will show you a short video so that you can gather an idea for this laboratory. Then after you watch the video, please do this activity because this is graded, and I hope all of you are participate. After you present doing your activity, please present here in front to discuss your work.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats, only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic, and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, two peaks or two troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelength can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distance and the bottom one is time. Pause the video, work it out and click play when you're ready. Did you get them right? In another video, we'll be looking at wave speed equation and connecting wavelengths and frequencies. For now, you just need to know what these four key words mean.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.
So, since you've done watching the video I present, I hope you gather an idea or information about the characteristics of a wave. Then you can now start doing your laboratory. And after that, please present here in front. Okay class, so by the way, your assignment for the next meeting, please prepare yourself for the next laboratory. I hope you understand and enjoy this laboratory. God bless and goodbye everyone.